Whew-wee. It is really coming down right now. I'm in the middle of an uncharacteristically warm January downpour at a time when the average temperature should be about 10 degrees Celsius cooler than it is right now, and all this rain would normally be falling as snow way up in the mountains. As a general trend, due to the impacts of anthropogenic or man-made climate change, extreme weather events like this are happening more frequently throughout the bioregion and the world, and they can create some really big persistent problems for the lands on which we all live. So let's take a look at this river here as a prime example. You see, every river has a different flow regime or pattern of high and low flows based on where the water in the system comes from, and these are generally defined as either rain-dominated systems, Nival or snowpack dominated systems, or glacially dominated systems, and each river system's flow regime is completely unique to their own and often a mix of different traits. These categories infer the annual flow patterns of a river and when water levels peak, which determines the way that each river has evolved to handle these flows, which affects the way that different aquatic species utilize these rivers, how humans and our communities use these rivers, and the broader ecological function within the watershed. For example, rain-dominated systems tend to have peak flows during the fall and winter time when the storms that come through drop a lot of rainwater that moves through these systems rather quickly. Nival systems or snowpack-dominated systems tend to have higher flows in the spring through the early summer when all that snow melts and releases the water into the system, whereas glacially dominated systems tend to stay colder for longer, with the majority of their meltwater occurring when they finally start to warm up in late summer and early fall. This river here generally has a mixed regime of rainfall and snowpack-derived water, so it's typical for its peak flows to be in the early fall when the weather is warm and moisture falls as rain, and then its levels dip during the winter when cooler temperatures store most of that falling water as snow up in the mountains. And then as things warm up in the spring, combined with warmer rains that melt that snow, we get a second peak flow during the spring runoff. Currently, this warm weather system is not only bringing a ton of rainwater, but the warm temps are melting much of the snow up in the mountains, which is causing an excessive amount of water to flood through this river system that it hasn't adapted to handle at this time of year, and as a result, there are numerous lasting effects that we'll be able to witness in real time. First off, this river channel and the surrounding riparian floodplain hasn't evolved to accommodate this high level of flows, and that, combined with the fact that many of these lands were heavily clear-cut logged and thus have reduced ecological function despite new trees growing back, means that these abnormally high flows create a lot of erosion and destruction of riverbanks as well as landslides. This creates sediment deposition downstream and freshwater habitat destruction, while also making it more difficult for those riparian forests to grow, succeed, and restore the ecological function they serve. Then up in the mountains, the lack of mature complex canopy cover in the forest, thanks again largely to clear-cut logging and improper forest management, exposes fallen snow to more sun and rain, which increases the rate at which it melts off. This rapid early melt-off of snow means that there will be reduced flow for this river in the spring and summer months when that snow would normally be melting, which not only impacts future water availability and human uses, but also the survivability of different salmonid species in these freshwater ecosystems that depend on that regularity, and thus the terrestrial species that all depend on them in the surrounding forests. And then, more broadly speaking, on a larger bioregional scale, that lack of snowpack and melt through the spring and summer means that the surrounding forest lands here are going to get much hotter and drier much more quickly than they would normally, leading to drought and higher risk of catastrophic wildfires in the summer months. So brace yourself for yet another smoky summer filled with water restrictions and evacuation orders. Super fun times. These are incredibly complex, interconnected issues, and while the progressive shift of these weather patterns is, as agreed upon by nearly 100% of scientists worldwide, the result of anthropogenic or man-made climate change, the impact that those changes are having on these specific ecosystems is very directly linked to the way that we have improperly stewarded these lands in the last 200 years or so. The lack of mature, complex riparian forest ecosystems to mitigate these swelling floodwaters creates lasting, widespread problems for the future health of these watersheds, and the lack of mature forest canopy cover at higher elevations significantly contributes to faster snowmelt and runoff. So while addressing the root causes of anthropogenic climate change is a crucial part of slowing the rate of change occurring, preserving the remaining intact ecosystems we have left, ending clear-cut logging, and working to restore the biological and ecological complexity and function within our watersheds plays a major role in mitigating these impacts to create a healthy, livable planet well into the future.